All right, everyone, welcome to our AI Trends 2023 series. Each year, we invite friends of the show to join us to recap key developments of the year and anticipate future advancements in the most interesting subfields in AI. And today, we're joined by Sameer Singh. Sameer is an associate professor in the Department of Computer Science at UC Irvine and a fellow at the Allen Institute for Artificial Intelligence, or AI2, to talk through some of the key research developments in NLP. Of course, before we get going, take a moment to hit that subscribe button wherever you're listening to today's show. And you can also follow us on TikTok and Instagram at TWiML AI for highlights from every episode. All right, let's jump in. Sameer, welcome back to the podcast and our trend series.
Yeah, thank you for having me, Sam. It's great to be back.
It's super excited to have you back. We were joking a little bit before we got rolling that we picked big years to have you on. The last one was our 2020, right in the wake of GPT-3, a big year, and of course, this has been a huge year for NLP with the relatively recent release of ChatGPT.
Yeah, it's always kind of crazy when you have these big changes happening in the year where there is research still going on in parallel and people are exploring research questions, and a lot of them uh, either become obsolete or have to be revisited and things like that in the middle of the year. And in this year, especially, it was much closer to the end of the year. So looking back at a year, it's always interesting to think about the trajectory and what ideas will still persist and what won't.
Yeah, yeah, no, that's a great point. ChatGPT happened right at the end of the year. Do you think we'd have this same sense that this was a huge year in NLP if it wasn't for that late year release of ChatGPT?
Oh, I definitely. I think this year has been really impressive. I would say even bigger, even if you take out ChatGPT. Overall, this year has been really big for NLP, even compared to sort of the year GPT-3 came out. So yeah, I think they've been. I feel like it took us a while to come in terms with what these large language models are capable of, or what they clearly fail at, and what they are good at, and try to sort of build better tooling around it, build better support systems around it. And so, yeah, I think this year has been good, even if you don't take into account ChatGPT. Yeah.
Awesome. Well, we're going to dig into ChatGPT in a fair amount of detail, as well as some of the other advances you just hinted at. But before we do, I'd love to have you take a few minutes to just kind of introduce yourself to our audience with a focus on kind of your research focus and what your interests are.
Cool. Yeah. So I've been working in NLP for a long time now, but my focus has mostly been looking at when these language models or machine learning in general gets interfaced with real users, what are the needs that sort of are there. So a lot of my work has been in explanations and interpretability, but also in robustness, both from an adversarial perspective, but also from out of domain generalization perspective. And also in terms of evaluation, like how do we know whether the models are doing well, how well are they doing, and in general be able to understand and predict when the models would work and when the models would not work.
And I'm imagining that the advent of large language models and the kind of the dominance of that approach to NLP modeling is well, it certainly changed the tools and the approach that you take. Has it changed kind of the fundamental way that you approach the problem?
To some degree, yes and no. I think it has made a lot of my work obsolete in the sense that we were doing a really good job of finding fundamental faults in a lot of these language models, and turns out a lot of them go away when you have a lot more data or a lot larger size. And so the specific observations and insights we had, not all of them have persisted. But the other differentiation we had in our work was always being somewhat model agnostic, or try to use a black box approach to the model rather than looking inside what's going on. And that is something that you can use, in this world of only access through API. A lot of those tooling can still work out, right? So yeah, so it's been a mix, but it's been exciting to sort of continue to do that. Yeah.
Well, you've identified some themes that, from your purview, have been some of the key topic areas and research that have emerged in the field over the past year. Let's start there, and maybe before we dive into any of the individual items, what's your take on 2022 broadly, and some of the areas that you were most excited about in the year?
Yeah, so I think broadly speaking, and we'll delve deeper into a bunch of these topics, but broadly speaking, I think the importance of data and the importance of looking at what might be in the pre training data has sort of brought up back into the focus in a way that I feel earlier years we were a lot more agnostic of what the model was being trained on and just more data was better kind of thing. This year, it's been a lot more sort of thinking about what goes in the models, and also thinking of ways to use the models not just by simply prompting it with a simple thing, but trying to get it to reason, trying to get it to break down the problem into pieces, and try to evaluate how much the language models can do that. And that I think is key when you start thinking about taking language models to more higher level decision making or higher level reasoning.
Awesome, awesome. What's the first area you'd like to dig into?
So let's actually start with chain of thought prompting. This is work coming out of Google that came out earlier this year, and I guess the easiest way to summarize is to say let's think step by step. Right? The idea here is to have the model not just generate the answer directly, but try to have it go through the reasoning process and then arrive at the answer. This ended up being quite a strong like a quite an effective method to get the model to do a lot of things, especially when it comes to mathematical reasoning and sort of where you can break down the problems into a bunch of reasoning steps. Chain of thought prompting did extremely well compared to what we had before. And part of the difference, I guess, was you're not just prompting with questions and answers, but you're also prompting with something that is much more detailed. So the prompt itself has a bunch of examples of breaking the reasoning down, and then you have the model being able to walk through that reason and get to the answer.
And in that work is the idea that the user of the model should break the prompts down into more detail, or that the model should learn how to kind of show its work and, given a coarse grain prompt, break the prompt down itself?
Yeah, so I think the initial paper focused on the user providing a few examples of this breakdown, right? So if you're saying, like, here's a mathematical word problem, you have two apples, and then somebody gives you double of that. How many apples do you have? Breaking it down into, oh, double means times two, and two times two is four. I mean, this is a very simple example, but this kind of giving an example or two of breaking this down can be quite powerful for a language model. Especially I think one of the key insights here, and we can talk about uh, other papers that sort of showed related things, but this is a very emergent property that seems to exist for really large language models. And as if you have smaller language models, it's kind of difficult to get them to do this kind of reasoning. So that's also been exciting to see.
Did the results there, did you find them surprising? Were they counterintuitive that, that would work?
I think the how well they worked were I think it surprised everyone because it's a very simple idea to just break it down a little bit. Everybody kind of assumed that the transformers are sort of either doing this internally or completely not doing this internally, right? And by showing you that if you actually write it out a bunch of examples, these transformer models are able to do this to the extent that they are, was quite surprising, and the gains were quite impressive.
Can you talk a little bit about the evaluation of that method?
Yeah, so the evaluation was mostly focused on mathematical word problems. So there's this GSMA and GSM8 data set, and then there's this MAWPS MOPS, I guess, data set as well. These are mathematical word problems. And this first evaluation was mostly looking at how well you can do a reason through some of those. And yeah, it was much better than anything that we had before. And then they had some evaluations on symbolic reasoning as well. So if you give them sort of tasks which have like 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 that have a bunch of so like finding a character inside a long string, like what is the fifth character, or something like that. You can break it down into a bunch of steps, and if you give it a few examples, it can do it. If you don't give it a few examples of how to break it down, the models are very bad at it.
And have you seen any work that looks to extend this beyond the kind of math and symbolic domain?
So beyond, I'll talk a little bit about some of the related ideas and sort of question answering a little bit later. But there is one work that is related that I like. This is called algorithmic prompting. And this is stuff that came out of Google Brain as well. So, a lot of this stuff is coming out of Google Brain because you need really large language models to be able to even work with this. So even bigger than GPT-3, for example. In this algorithmic prompting paper, this was kind of interesting, where they had essentially the same idea as chain of thought, except that they go really detailed into what those reasoning steps would be. So they mostly focus on, things that can be described more as an algorithm rather than as just breaking it into a few pieces. So you can say things like, if I had to add 12 plus 24, right? How would you do that? They literally break it down into digits. Oh, you take the ones place, that's two in one case, four in the other. You add them up, you get six. There is no carry. Okay, that's one. This the second step is, okay, now look at the next tens place. It's one and two, add them up, three. Look at the carry. Oh, the carry is zero, so it's just three, and then 36, right? So all of this very detailed breakdown, which looked like extremely detailed. But what was really impressive to me about that paper is they showed that you can give examples of really low digit operations. So, like maybe 2 or 3 digit operations when you're talking about addition or multiplication, or any of these things. But at test time, you can, firstly, even on 2 and 3 digit stuff, it was much, much accurate compared to regular chain of thought. Like, 20%, going from 80% of for chain of thought to something that's 100%. I'm kind of making up numbers.
And this is relative to asking for the model to solve the same problem without any intermediate steps.
No, so without intermediate steps is even worse, right? So this is asking the model to, so like 12 plus 24. I don't know exactly what the chain of thought would be, but it would be something that would be at a higher granularity, let's just say, right? And and so when you give these detailed prompts, the models are more accurate, which is not so surprising. But what was surprising was that they kept increasing the uh, size of the number at test time. So started adding more and more digits, and even up to 18 digit numbers. The model is able to do really these operations much more accurately, even though the prompts were only on 2 or 3 digit um, sort of numbers, right?
And so does this type of work answer definitively whether this is already happening inside the model versus there's some other effect? Like, in a sense, it's really counterintuitive that it would work at all. Like, there's no registers inside the model that are tracking digits, the ones place and the tens place. Like, why should that work?
Yeah, so I think there are there are people are still trying to come to terms with why chain of thought reasoning works. Is there something in the pre-training data? Is there something in the model? And there's been some interesting work there. But no, I think the tricky thing here is you're making all of these things explicit. So you're not relying on the model to keep these bits somewhere latent in its sort of memory, right? Like, you're making it explicit, and of course it's attending to all of that. And so the chances of it sort of going away into a wrong place is much lower. And Scratchpad and a bunch of other papers had similar ideas of like, hey, let's give some model some space to think about things, right? So it's possible that this is just letting the model actually think things through. So it's somehow more computation that the model is getting. And there have been some papers showing that, yeah, that might be the difference. The fact that you're generating a single number, but you're letting, not just asking the model to give it one shot, but letting it think about it. And and it's not so much the fact that you're giving these example breakdowns that helps, but I think, as many of these things, I'm sure the answer is complicated and it's some combination of everything.
The last thing you said almost sounds like the kind of multitask argument. It's not that, the specific other thing that you're asking the model to do matters, but that you're asking it to do another thing, and that kind of, on the traditional side, like has some kind of regularization effect or some kind of effect that causes your results to be better just by overloading the model a little bit.
Yeah, exactly. Right. So you're letting, in some sense, you have more activations, you have more latent states. You just have giving model more things to do, and so it has space um, to explore through more reasoning. So maybe that's one explanation for why this kind of stuff works. But yeah.
Amazing, amazing. And I should have mentioned earlier on, but I will mention it now. All of the papers that we're referring to will be available on the show notes page so folks can check them out. So the next thing that you had on your list was decomposed reasoning. It sounds like it's in a similar vein.
Yes, so I think this is that's why I kind of put them together. But I think fundamentally this is a very different approach to the same idea. So yes, I think terminology is something that the field is going to be revisiting, and decomposed reasoning is kind of something that I came up with. I don't even know if people use it, but the idea here is that there've been a bunch of papers here, and I'm just going to sort of quickly run through some of them. But the idea here is that you shouldn't rely on the language model alone to do the whole task. Right? So suppose I give it a mathematical word problem, or if I give it a question answering problem that's a lot complicated, I shouldn't rely on the model and its parameters to be able to carry everything out. Maybe the model needs to use a calculator. Maybe the model needs to do a web search. Maybe the model needs to even write a small Python script and actually run it to get the answer that I want. And so this whole idea, and yeah, of language models getting what you need, but not just relying on its own parameters, but breaking down your problem and figuring out, oh, I need to call something else, and this is what I'm going to do to call it, uh, is an idea that sort of came out post chain of thought, sort of middle of the year. But there have been a bunch of papers all the way to the end of the year that have been doing a lot of this. So yeah, it's kind of been exciting. A lot of them have been on the QA side of things. So the two I'll mention is successive prompting that came out of my group, but there's also decomposed prompting that came out of AI2. And the idea behind both of these was to take a complex question, break it down into simpler ones, and then have the language model sort of call another language model that is answering each of these simple questions, right? So if a simple question is a mathematical operation, then you would use a calculator. If a simple question is a very simple lookup question, then you would use something that is like a squad style question answering system, things like that, right? So being able to take what the user wants and breaking down into pieces and then composing the answers together to give you the actual answer is the kind of stuff.
Can you talk a little bit in a little bit more detail the difference between successive prompting and decomposed prompting? How do the settings for those differ?
They came out pretty much around the same time, so it's difficult to sort of, and they sort of appeared at the same conference as well. I think, yeah. So I think some of it depended on sort of which data set they use. So decomposed prompting used explicitly multi-hop data sets and sort of tried to decompose it that way. Successive prompting focused a little bit more on calculations and symbolic operations as well. So yeah, I would say the differences between them are
But kind of same idea, different data sets, slightly different tooling.
right. Yeah. And we'll see in some of these cases other pairs of papers also that are very similar that came out around the same time, because that's where we are. Yeah.
And how about tool augmented?
So tool augmented stuff. So there was a paper coming out of Google, I believe, called Tool Augmented Language Models. So TALM is the paper, and this is one of the papers that was essentially showing that you can have instead of just calling a calculator explicitly or just having a fixed set of things, you can create a description of APIs that the language model has access to, and have the language model itself generate example calls to that API when it's doing an output, right? So if I want to say like, hey, GPT-3 or whatever, how hot is it going to get today? Right, or hot is it going to get today in Irvine? The language model is going to say, okay, this is a question about the weather in Irvine, so I'm going to compose an API call to a weather service, right? That's going to say, what's the weather in Irvine? And then it'll return some JSON object that says, oh, the high is this, low is this, probability of rain is this. And then the language model will kick in again and take that output and say, oh, it's going to be pretty hot today, as since it is Southern California. And yeah, something like that.
Seems like this research is heading in the direction of how would you kind of rebuild Siri or Alexa or something like that with LLMs.
Yes, yeah, and I think this is one of the key sort of advantages of these language models is not that they can do additions and subtractions internally. Like I think that's interesting from an intellectual point of view. But when you're making actual products, you want this language model to language is a way to interface with things that are external to you, right? So the language models should take in the user queries, but also be the interface to other things outside and be able to query it. I think we will talk a little bit about that later. But one of the reasons I like this is you can also somehow now attribute the answer that you're getting, not to some internal parameter in the language model, but to say, look, this is the API call I made, and this is the answer I got, and now that's the answer I gave you. So in some sense, it becomes a little bit more attributable.
The idea of the language model writing a program to figure out the answer to a question is a fascinating one, and it almost feels like if anything that anything around LLMs is going to be the path to AGI, it's like it's that. Like, what was your reaction to that research?
Yeah, I think it seems quite like to me from a practical point of view, it seems quite exciting, right? Like so, and from a code generation point of view and things like that, it's useful as well. But the nice thing about the code writing code is that it's unambiguous, right? So it's making some calls to an external database. If I want to update the language model, or update this whole system, I can just update my knowledge directly, right? The knowledge is external somehow to the parameterization of the language model. That makes it super convenient to delete things or to add things or to get attributions and all of these things. And the interface to that data source is always programs. Either it's like a simple API call or a more complex one. And I think I really like this idea because it allows the language models to do things that it should be doing, which is to understand language, or let's not call it understand, but be able to parse language, be able to sort of transform it, but doesn't necessarily have to know the temperature of Irvine every day or things like that. Right? Like that's not something I necessarily want in the parameters of the language model.
Yeah. So just very subtly in there, you um, kind of addressed another big conversation that's happening in the community now, and this idea of, do language models understand? You call this decomposed reasoning. The thing is writing programs that kind of require some kind of reasoning. Like, what's your take on these broader questions about reasoning and understanding in LLMs? Or would you like to defer that? Is there a natural point later for us to talk about that?
Come back to it a little bit later, maybe even in the next section of sort of we us trying to sort of question what reasoning is and trying to evaluate that in some sense. But yeah,
The semantic argument around understanding, like, that's not that interesting, but like how a language model can reason, and the extent to which it's reasoning versus like cutting pasting at some level beyond at an impressive way, like that's kind of really interesting.
yeah, definitely. So I would say, and then even pushing it a little bit further, like what are the consequences of the fact that it is cutting pasting versus its reasoning, right? Like, so how should we calibrate what things this should be deployed for and what things this should not be deployed for based on these intuitions? Those are the kind of things that I'm really interested in.
Awesome. 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 Is that your next section?
Yes, and that sort of ties in very well with what I think is exciting next, which is I'm going to call it sort of understanding the relationship between the data, the pre-training data, and the output of the model. And I feel like there is again a few different threads here, but there is one that came out of my group that I think is a simple idea that really sort of captures exactly what you said: the cutting pasting versus a reasoning thing. So this paper is called "Impact of Pre-training Term Frequencies on Few Short Reasoning." And the idea here is we were looking only at numerical reasoning right now. So we started looking at all of these examples of, hey, GPT-3 can do addition and multiplication and things like that. And we started looking at the instances, and turns out that it doesn't always do it, right? It's not 100% at those. It's 80% or 90% or whatever the number is. So we started looking at, okay, what differentiates the one it gets correct in to things that it doesn't get correct in, right? So for example, we saw that if you ask it what is 24 times 18, the model gets it right. It says 432. If you say what is 23 times 18, the model gets it wrong, right? So 24 times 18 is correct, 23 times 18 is not correct. Is this random? Like, what's going on here?
And did you, just to interrupt there, did you find that consistent across invocations? I've run into that kind of thing. We've all run into that kind of thing playing with ChatGPT and other things. And sometimes it gets certain things consistently wrong. Other times it gets the thing wrong sometimes and not wrong other times, like it's a random seed kind of thing or something else going on in the model. Did you explore that at all?
Yeah, we definitely saw that. So it's both like if you're doing few shot prompting, which examples you put in the prompt would sometimes change the output, or how you phrase it. Like you say what is 24 times 18 or what is 24x 18, things like that. It definitely made a difference. But even after averaging these things out, we saw that 24 times 18 was in general more accurate than 23 times 18. And even more than that, we did even further analysis. And it turns out that all of our instances that involved 24, the model was much more accurate on than all of the instances that involved 23. Well, so we decided to do this for everything from 0 to 100.
Okay.
So all two-digit numbers, essentially, single and two-digit numbers. And no, it's a whole spectrum, and we didn't see a clear reason why some things are low accuracy, some things are high accuracy. And so then what we decided to do, this is the part that I think I got quite excited about. We decided to count how many times do each of these numbers appear in the pre-training data. Right? And turns out, and you can see the plot in the figure, uh, if you plot the log of the frequency of these terms and now how accurate the models are, it is pretty much exactly like a
Which is intuitive. The model does better on things that it sees a lot of, right?
yes, yeah, but yeah, so it's also expected, yet disappointing because you don't want it to be such a nice, strong curve, right? Like you want it to,
Right.
like if it's doing mathematical reasoning, it should know that 23 is one less than 24, and all of these things, right? So uh, I think it's one of these things where it was expected that the model would be better at things it has seen before, but you also at the same time hold this thing of like, oh, it is able to reason, it is able to do these things, and it's kind of difficult to resolve both of those, right? So this was one example. I think this we are barely scratching the surface, but this was an example of a paper that sort of started looking at some of these pre-training statistics, so not just single term frequencies but bigram frequencies and things like that, and showed that the model is quite sensitive to what these things should be, right? And I don't want to sort of make a claim that there is cutting pasting going on or any of these things, but this effect is so strong that at least when we think about reasoning and when we are evaluating reasoning in these language models, we should be taking this effect into account somehow.
And this may be a side note. It looks like the model that you evaluated with GPT-J and the clearly that's a model. It's an open source model that you had access to the pre-training data. It kind of asks questions about how do you get the same kind of insight into these models that are behind APIs.
Yeah, so I think the question is like I kind of don't mind that models are behind APIs to some degree. That commercially that kind of makes sense. It feels a little bit disappointing that the training data also is behind sort of closed wall, right? So like
Mm.
I
Hmm.
know that there is a lot in the training data, but if we want to be able to understand like why ChatGPT works or why GPT works or even generally like when do language models work, when are they safe to deploy, all of these kind of questions, I think it's okay if the language model we only have a black box access to, but it would be good to have access to the training data. It would be good to have access to a bunch of these other things that can help us sort of do simple kind of analysis like this and maybe more complex ones, and actually be able to sort of decide what to do with the model. Okay? So I think this whole direction of trying to understand what's in the pre-training data, I think, is key and something that will persist for the next couple of years.
Do you think we have the right tools to do that at scale? I'm imagining that was not an easy task to do just for simple mathematical problems.
That's true, but training GPT-3 is also not a simple problem, and people have solved it, right? So I think so I think the tooling is something that everybody right now is uh, sort of excited about building tools that actually give information and insights into these language models. And I think, even at AI2, we are at sort of early stages of trying to do these things of building some tooling that can support this kind of analysis. But if the data set is available, I think people will do amazing things. And uh, I thought this would be impossible, and it seemed like crazy. Like, hey, this is almost a terabyte of text. Like, how can you do anything with that? And it was not trivial, but it was easier than impossible.
How do you identify, so you identified some behavior, um, the relationship between accuracy and frequency in the training data. How do you identify what that is a consequence of? Meaning, is it specific to the way GPT-J was trained? Is it all transformer-based language models? Is it, maybe something about that particular data set? Like, are you able to say that it is a broad characteristic of LLMs in general based on the work that you've done thus far?
That's a little bit difficult to sort of that's a little bit difficult to measure, partly because we don't have data set available for too many models, right? So at least we tried the whole sleuth of the Luther models that were trained on the same data set, and we saw um, similar effect on different model sizes essentially. And yeah, as data sets become pre-training data sets become more standard, it's fairly trivial to sort of extend this stuff. Since this paper, we also have sort of an online demo where we have a bunch of more tasks that try to go beyond mathematical reasoning. It's a little bit difficult to sort of even define what these sort of terms are and what you should be computing frequency of. But yeah, I think we should be able to do this stuff for other tasks and for other models. And to me, I think this is somehow a consequence of a language modeling loss that encourages this in some sense, right? So um, like, yes, the model has seen more and it'll be more accurate, but even the ones that it has seen less, like, it has still seen millions of times. So there is no reason for it to be wrong on it, except for the fact that the language modeling loss would sort of want you to be more right on the ones that it has seen more.
Mm-hmm. 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 You had another paper identified out of Yoav Goldberg's group.
Oh yeah, so this is work led by Yanai. I think I'll quickly talk about this. So this had a similar sort of intuition for like trying to look at things in the data and trying to figure out like why the model is has certain biases or has certain errors. And this was sort of a little bit more on trying to identify when two entities are related, right? So if you say where was Barack Obama born, the model tends to say Chicago, or in some sense it can say Washington, and depending on how you phrase it. And like, why does it give the wrong answer? Right, is kind of the question. Why does it not say Hawaii or something? And I think the to be able to answer this question, you have to go back to the pre-training data and try to see, like, okay, what did it even see? So what I like about this paper is it kind of tries to use causality tools, and builds a whole causal graph for where these kind of predictions might have come from, and then tries to estimate all of the edges in those causality graph, and tries to do some causal inference to sort of attribute it to specific uh, statistics of the pre-training data.
So in this causal graph, would each individual document in the pre-training data be an intervention of sorts?
So they sort of worked. They worked at the level of, I guess, triples or something like that, right? So let's say you see Obama in Chicago being a senator there or something, right? So this is kind of a triple, and so they work on statistics of those triples over the pre-training data to sort of make it tractable and make it sort of allow this inference to work. Yeah.
But in applying the causality machinery, like are each of those interventions relative to some prior relationship between the things, the triples?
Yeah, so there is the true relationship between these triples, and then there is the observed relationship between these triples, and how many of these things, how many times it appeared in the pre-training data. And so the idea would be, when you're doing it over many different entities and many different relations, do you so those kind of become your whole data set in some sense. So Obama has appeared in Chicago, but Hillary Clinton has appeared elsewhere, and all of these things, and then together, which of these causal which of these relations seem to affect a specific prediction the most, that kind of stuff.
Awesome, awesome. Kind of continuing on in the data theme, there's been a ton of work looking at the need for clean data. I think maybe one of the most surprising things for me is like the return of supervision at the scale of LLMs. Talk a little bit about this category.
Yeah, so this was somehow the most surprising category for me, for this year. I will say that, like, after GPT-3 came out, and at the end of the last year, everybody was kind of excited about language models, but the solutions for what's next always seem to be like, hey, let's get more data, and let's get larger models, and let's train longer. And those are still sort of useful things, nobody's denying. But this year has shown that, like, hey, you can actually do a lot if you're a little bit careful about your data, right? And maybe if you start cleaning up your data and try to think a little bit about where the data, your pre-training data, should come from, your pre-training data itself, that could be quite interesting.
So when you think of like RLHF as an example, do you think of that as fundamentally just cleaning up your data, being more careful about your data as opposed to
Yeah, so no, I think I was thinking more what happened with the Bloom language model,
right.
which was trained on sort of a lot more thoughtful process of gathering the data set. Because, I mean, partly because they documented it and we know what sort of they went through. But no, like RLHF, and those kind of things, I think, are examples of showing that the language models are not quite ready for use case, just based on pre-training on sort of large data that has been gathered. You need to reinforce, like, you can call it like, hey, cleaning up the data, but I think of it as like maybe reinforcing some of the nice signals in the data, by having these examples. Or in some sense, people have been fine-tuning on this sort of supervised data as well. And the gains that you get from RLHF have become extremely evident this year, right? So somehow that has become the secret sauce of OpenAI and of all of these companies that want to have really strong language models rather than scale and just raw pre-training data.
Mhm. And for completeness, we've talked a little bit about RLHF on the show, but how do you think about it as a researcher?
I think it's quite exciting. I think it sort of addresses a lot of my concerns with language models. I don't think pre-training data can be trusted, right? And you shouldn't just train something and expect the model to have clean output or have uh, you know your values and any of these kind of things. Whatever that means in the context of large language models. But essentially, if you want real users to be interfacing with language models, you need to make sure that there is some sort of check. And RLHF is not the solution, like a full solution, but at least there is a way to sort of say, okay, this is the actual task. Your actual task is to be interfacing with humans, not just regurgitating what you've seen in the pre-training corpus, right? And so that intuition sort of is captured by using RLHF.
And do you remember offhand any of the if they were even published the stats in terms of the number of prompts, like human generated prompts that were used in ChatGPT or Instruct GPT?
Yeah, I
They,
don't think they were published as far as I know. Yeah, I don't remember exactly what they are. I think Instruct GPT had the documentation of sort of how they were gathered, but the size was like, how many of them were sort of generation tasks versus classification tasks, things like that. But I don't think the exact data set is available.
do you have a guess as to like the relative cost of of collecting the human feedback relative to the cost of training the models?
Oh, relative cost of training the models. I think it's much cheaper.
Order of magnitude, or is it like much much cheaper? Because we always say like collecting the data, label data, is the most expensive part of machine learning. Is that still true at the scale of LLMs, or is it that RLHF is like extremely efficient and you just need a little bit of guidance on top of the pre-training data?
I feel the true answer is somewhere in between. So I don't think it's nowhere very little data. Like I think you need a lot of data to be able to do it, but I don't think it comes close. At least the way these are trained right now, I don't think it comes close to sort of training the model itself, right? So, but like when you think about Chat GPT, it's been released publicly, and a lot of people are using it. A lot of that data is going to go into in some form back into the model and improve it. So uh, was that expensive to collect? In some sense, because they had to run ChatGPT, but you know they'll probably pay some annotators to clean that up. But I don't think that's going to compare to the actual training.
It's also a really interesting example of like bootstrapping. Like there's a certain amount that they collected themselves, the Instruct GPT work, and then they created something that was good enough to set loose in the world, and now they've got this virtual cycle where I'm imagining it's a lot cheaper for some annotator to clean up what millions of people are creating than for them to create that themselves.
And I think this year has also shown, maybe even to people at OpenAI, that the value of these things, right? Like when they released GPT-3, they probably didn't realize how valuable this would be, and then they sort of collected data, released Instruct GPT, and yeah, on their benchmarks it was good, but once people started using it, you realize how much better it is. I think similarly with ChatGPT, they probably knew how good it was, but they probably didn't realize how good it actually is, right? And I think this idea of human feedback being a secret sauce that is proprietary, I think can sort of will continue to be a bigger piece in the future.
Mm-hmm. Mm-hmm. Talk a little bit about roots.
Yeah, so the roots is this nice data set that was gathered by the Big Science group, and I've been following the Big Science group, and they've done a bunch of interesting things there. It's just
I guess I'll jump in to refer to the interview that I did with Thomas Wolfe. That I don't think roots came up explicitly, but we talked about that work and the that eventually resulted in Bloom, which we'll talk about a little bit more as well.
yeah, so roots I like because I think I really like what Luther have done with the Pile dataset by releasing the dataset that was used to train all the GPT-J models. And I think the Big Science group sort of took that intuition and sort of went further with it, where they have a really well documented, uh, and not just well documented, I would say a very thoughtful process of gathering this data set. It's multilingual over many different languages, and they've been careful about sort of listing which sources they want to even crawl in the first place before. So it's not like a post hoc cleanup of the data. It's very sort of thinking about it. They gathered a data set that is huge, and they have, and we'll talk a little bit about this later also, but Hugging Face has sort of built tools on top of it to be able to quickly search it to see what's in it, and stuff like that. And I kind of like that approach to large language models, right? So I think getting the right data set is crucial for these language models, and doing this documentation and stuff is good for in the long term.
So your next category is decoding only. Talk a little bit about what that means.
Yeah, so this is a theme that I like about some of the work that has come out here, and partly it's because we have these language models where we have this black box interface to them, and a lot of it is just prompting, so changing things on the input side to see what the model generates, and the only thing most people are changing on the output side is like, oh, let's change the temperature a little bit, and we get a bunch of different things. But there has been a bunch of work looking at, okay, let's not just do that. Let's actually think about what's happening in the output of the model during decoding of the text. And maybe we can do smart things there that actually sort of change the output considerably, right? So some of these sort of came out sort of late last year. So there was this work on nucleus sampling. Maybe that's a little bit older, but then there was this stuff on sort of constrained decoding as well, where the constrained decoding paper came out of semantic machines. They showed that you can have, suppose you want the language model to generate programs, right? So the programs come with a certain grammar, right? Like there is a syntax that they need to follow. So you could actually constrain the output of the language model as it's generating token by token to sort of adhere to that syntax in some sense, right? And just by doing this constraint, you can get, firstly, obviously, you will get programs that are syntactically correct, but you can actually get the right things out of the model. And so there have been a lot of sort of works looking at um, how can we decode by having some constraints on the decoding. Right? So one of the papers that came out this year that I believe got the best paper award as well is called Neural Logic A star esque decoding. And the idea here is that instead of just doing left to right decoding where you're being greedy or where you're doing some kind of beam search or sampling or any of these processes, why don't you actually use some of the computer science ideas that we have, like A star search, right? And try to find the best possible decoding. Um, um, and then when you're doing this kind of thing, you can also think about constraints that you might want to put on the decoding. So you want to say, look, I want the decoding to have these 3 words in it, right? Like, hey, you're generating a recipe, make sure that it has these 5 ingredients, right? Somewhere in the generated text. You can also flip it around. Hey, generate whatever text you generate, make sure it doesn't have these specific words, right? Things like that. And this paper sort of uses A star during decoding to generate that text that sort of your constraints are satisfied. And this paper showed that once you do that properly, you can actually do a lot of the tasks much better just by controlling decoding rather than changing much on the input side.
It seems like this is another example where uh, it's predicated on having open access to the model internals, and you potentially lose a lot if you don't.
Yeah, I think so. From what I understand, you can still do these kind of things with GPT-3 to some degree. I think what you need, you can, okay, so you can do this with black box model as long as you get the probabilities of all of the tokens at every step, right? So I don't think GPT actually does that, but you could imagine an API that says, okay, here's the distribution over all of the tokens. And you should be still be able to do these kind of ideas. So some of the concerns is like if you want decoding to be fast, then it's difficult to use some of these ideas. The A star one specifically is a lot slower, but it's able to satisfy your constraints. So it can be where you're okay to trade off some time, but let the model take more time in making sure the output is clean and satisfies your constraint. This could be a really really cool use case.
And now, yeah, often you see, hey, we applied one method, A star in this case. Let's go back to the computer science toolkit and apply everything else. Have we seen that here?
Not yet. This I think came out late enough in the year, but I guess it came out sort of early in the year. But yeah, we haven't seen that much yet because. But I think yeah, that's the kind of thing that will happen next. Is like okay, now this is yeah, this is attracting a whole different kind of thinking where people were not thinking about decoding at all, and now they will be in this light, which is always a sign of a good paper.
Awesome. Awesome. Well, those are great themes to kind of reflect on as we think about the past year in NLP research. Our next category is to talk about some of the new tools and open source projects that we saw in the year. We've already talked a little bit about data sets, which is kind of related. But I think the first thing you have here is OPT. Tell us about OPT.
So yeah, I think OPT came out fairly early in this year, and I think it kind of surprised everyone because the sort of looking back at last year, there weren't that many open source reproductions of large sizes, right? So I think Luther AI was sort of leading it. GPT-J was 6 billion, and they were sort of growing it slowly and slowly, and they had got to 20 billion parameters. And then OPT sort of came into the scene, and there were a bunch of nice things. They documented a lot of their whole training process in a logbook with sort of all kinds of insights about what training a log. Yes, it was released by Meta, right? And that was also not to say too much against Meta, but it was also surprising that reproducibility and open source seemed to be key aspect of OPT as well. So that was kind of nice. And they also released a lot of models, and like all different sizes, including 175 billion, which hadn't been uh, available at all. And even right now, I think it's the probably the most useful model if you want to do stuff with 175 billion is to use the OPT model, right? So I think the idea of documenting the whole training data gathering process, documenting the whole training of the model process, and then releasing all of these models available for research, I think has helped the research community a lot. And I expect that if there are people who want to build models and potentially fine tune language models and do all of these things, the OPT would be a pretty big resource.
Have you seen much in terms of benchmarking it against GPT-3?
Yeah, so I think people have been benchmarking it, and I think it performs reasonably well. The tricky thing is, of course, there is Instruct GPT, which is when you call GPT-3 on the API right now, it's often defaults to the Instruct one, and that one is a lot more difficult to beat. But for all of the purposes, I think of it as like OPT is basically same as GPT-3.
We talked a little bit the big science project and one of its outputs. Another is Bloom. What was your take on Bloom?
Bloom was again a really big a model that was, I think, 180 billion parameters, so similar size as GPT-3, released to be completely open source with, like we talked about, completely well documented data process and sort of training process, combined with the fact that this was done by a group of people kind of just volunteering their time to do so, and them being able to reproduce to a large degree what OpenAI has done was quite amazing, right? And sort of again, like both OPTs releasing all of these things is kind of a sign for other big tech companies to say like, hey, you can do this because we have done this kind of thing. What Bloom has shown is that a bunch of people, enthusiastic and excited folks that are enterprising, can actually do things that maybe even a year or two ago would have seemed impossible.
It may have been in our trends conversation from last year, or maybe it was prior. But in these kinds of conversations, there was a point in time where we were lamenting the kind of the loss on the part of the individual academic researcher to contribute to fundamental model research because of the resources that were required. And to Hugging Face and the big sciences team, like, they showed that not necessarily, not so fast, right?
Right, exactly.
Yeah.
And the other thing I like about this, the Bloom effort is, and the corpus that came with it, they were also focused on being a lot more inclusive in terms of having a global perspective. So they were trying to cover many different languages.
Very principled in the way they pulled the data together.
Yeah. And also multilingual in a way that none of the existing models have been. So yeah, it's quite exciting.
And so, like, conceptually, this is a great example of how you know one model at 175 billion parameters and another model, the same number of parameters, could be very different, at least in the data that they were trained on. And you would expect that to result in very different results using the model. To what extent have we characterized that, like, at that scale of data? It's still a lot of data, it's still a lot of, like, raw internet data. Does it all kind of fall out in the wash, and all their efforts at being principled, kind of just get lost? Or do we know how to compare that?
Yeah, so there have been a bunch of benchmarks, and including in their papers, but in general also, and that's where sort of the, I don't hold me to this, but I would say like Bloom is not the go-to language model for people if they want to do English things right now, right? So I think maybe some of the trade-offs they made in collecting the data, or even just having more languages, uh, resulted in a model that's definitely really good for multilingual things. But that's not what our benchmarks have been designed for, unfortunately. And so if you just look at the benchmarks, like, which are traditionally designed for English, Bloom, I don't think quite is at par with OPT or GPT-3, and definitely not with instruct things.
And when I mention benchmark, there's that aspect of kind of applying the traditional performance benchmarks, for LLMs to Bloom, and comparing their results to the others. But I'm also curious about how we characterize, like, qualitative differences between the way Bloom responds, and the way GPT responds. For example, in terms of, like, the kind of fairness considerations, or that kind of thing. Or, are there qualitative differences in the kinds of responses that you get that aren't picked up by the traditional benchmarks? Or are the traditional benchmarks, like, so expansive at this point, we've kind of characterized a lot of that stuff explicitly?
Yeah, again, I think the answer is somewhere in between. So I don't know if people have thoroughly compared the two to see, like, hey, what's the level of toxicity, and things like that. Like, I think when OPT came out, they did a lot of this analysis in their paper of like, hey, how toxic is their model, how safe is their model, and they realized that, yeah, in some things they were worse off than some of the existing models. But I think the with Bloom specifically, I don't know off the top of my head how it sort of compared in terms of these other sort of other aspects. Yeah.
Okay. Talk about the inverse scaling competition.
Yeah, so this was a pretty nice thing that came out, and I think I suppose it's still going on, even though the submissions are down. So I'm kind of hoping to see what the actual effect of this was. But this was sort of introduced sort of in the middle of the year, and the idea here is the thinking of things like what sort of scaling laws was showing, right? Like when you scale up your models, performance goes up for everything. And that's kind of exciting to see. But it also tells us that uh, okay, there are many things that just the models would just get better on as time goes by, because they'll get bigger, they'll have more data set. The inverse scaling was this intuition to see, okay, what are can we characterize the phenomena that don't have the same trend, right? So Other aspects, you create a data set which is something everybody will agree is a reasonable data set, but when you give them to larger models, uh, they actually get worse, right? And so this prize in this competition is an effort to identify what those tasks would be, and sort of the better your inverse scaling is, so the worse the bigger models are on the data set that you've contributed, the more likely you are to win this competition. And so yeah, they've had the submissions and they're kind of evaluating them, I suppose, and they haven't quite announced it. But I think a lot of the stuff on, you know a lot of the interesting things could come out of this effort. So one thing I could imagine is sort of deeper levels of misinformation, where the model is relying so much on what it has seen in its training data. Now, let's not call it misinformation, just not being able to update its information in some sense, right? So these large language models have memorized so much about the pre-training data that they kind of reject evidence against that, right?
Maybe if they're smaller, there's less memorization and more
Exactly.
generalization in
Yeah,
some
yeah.
way.
But I
Yeah.
think it could be pretty exciting to see what are those things that actually get worse with scale. I think it's quite an interesting question.
And next up, you have the Galactica. Can we call it a debacle? So Galactica is this
Yeah.
LLM that Meta released that um, was tuned to generate scientific and research text, and was it even up for 3 days? Like it got pulled down pretty quickly, right?
Yep, yeah, I think maybe a little bit more than that, but yeah, thereabouts. Yeah, and I think to me, it's a story about how not in anything in terms of what the Galactica team did itself, right? Like I think the model training it, everything was the right thing to be doing. Um, the tricky thing was just how it was pitched and how there was just not clear caveats about what this model is capable of doing and what it's not capable of doing, that led to such a backlash, right? So I think it was a language model trained on a lot of science papers, so it's going to produce papers that look like scientific text. I think that was an expected thing. But again, the backlash it got and stuff like that essentially tells everyone, and I hope the message is not to demo language models anymore, but I think the message should be how to make sure that you're not hyping things up more than they should be.
If you reflect on ChatGPT, which came not very long after Galactica, um, and the launches of those respective products, is there a clear like do don't do list?
So I will say that ChatGPT itself was also not, you know, not completely without hype attached to it. Even some sort of how they,
Right.
yeah, right,
Somehow they managed it. There was a
right,
lot of
right.
hype.
Right. I will say that they were fairly clear about the fact that, like, hey, don't trust. Maybe they could have been clearer, but like, don't trust the factual stuff and things like that. Like, it's not a lookup engine. I think they kind of could have done a lot more of that, but they at least had some caveats. But more than that, they part of their RLHF stuff was to make sure that the model is not producing at least obviously sexist and
Mhm.
toxic
Yeah, there was a
and
lot, and maybe we're jumping into ChatGPT, which actually is the next thing we're going to talk about. But there was definitely a lot of, especially early on, things that it just would not opine on. Like, yeah, no, you're not going to sucker me into going there.
Right. Yeah. And I think when you're building something that's public facing, that you're selling as a tool, as a product, that is necessary, right? Like, I don't think you should be doing uh, otherwise. Galactica should not have been a public facing tool for every scientist to start using to write their papers. It should be a language model, right? And the what the product is or what the tool is a gap that other people can help fill in, right? So that was sort of the missing piece when I think about ChatGPT versus Galactica. It's like, yeah, ChatGPT has some of the caveats about what it's doing, has some of the caveats about, oh, it's a language model, not a product, to some degree. Um, and Galactica was missing it, right? So
We're there. Uh, we were talking about open source. Next up is kind of commercial developments. Top of that list is ChatGPT.
right, yeah, let's talk about it. Yeah,
It's you said early on that hey, even without ChatGPT, this was a huge year. That's clearly not to say that ChatGPT wasn't a huge contribution to the year. I mean, certainly one of the things that I found most interesting was the degree to which it kind of broke out of the MLAI echo chamber to just talking to random friends and are like, hey, have you tried this Chat GPT thing? Like, yeah, I have.
yeah. So that's been the, I guess, the most surprising and in some sense the longest term impact for ChatGPT is going to be the fact that it made it commoditized, it made it mainstream in a way that nothing before it had, right? And whether it deserved it or not, what the actual innovations are and all of these things is a different question, right? Like it is clearly even for research point of view qualitatively better than GPT-3. Whether it met some threshold for becoming the big thing that it did, it's sort of difficult to sort of in hindsight try to evaluate that. But I think it was yeah, it is definitely something that uh, became mainstream and everybody's talking about it. There is still a question in my mind whether that's a good thing or not in the long run, because we can talk about some of the problems with ChatGPT. The biggest one being we know it's a language model. Like to some degree we've been figuring out last couple of years what these things are capable of and what these things are not, and I can sit and in like couple of minutes come up with tons of examples where it would fail. um, that's not quite the case when you sort of start putting it out in the public, right? So most people don't know what a language model is, and I've played around with, I've got a bunch of my family to try it and things like that. And the biggest thing I've had, the biggest difficulty I've had conveying to them is the fact that it's not looking up anything when you ask it something, right? Like that is a conceptual jump that is very very difficult for
Yeah,
people to get over, right?
yeah.
And so people like, yeah, oh, of course it should know about these things because it happened yesterday and it was such a big news items, like why would it not know? And I'm like, no, actually it doesn't know anything beyond a certain time, and even saying it knows anything from then is a little bit difficult, right? So I think the best analogy that this applies to my research as well, but the best analogy I've had in trying to explain people what ChatGPT does is to not think of it as a stochastic parrot or anything like that. But if you have to think in terms of animals, think of it as like a chameleon. Like it's trying to sort of fit in to a bunch of humans, right? And it's trying to just write things that'll make it pass as if it sort of knows all of those things, right?
I was in a Twitter exchange about I had asked ChatGPT to explain uh, RLHF, and it came up with this acronym that was like I forget it, and it was really funny. It was like something leaderboard, human human something. It was so far off. Interestingly enough, I'd had conversations, interactions with it about RLHF, and then it knew what it was. Like to your point, it's about kind of where it sits in the context of the prompt. And I just kind of posted, is it trolling me or is it like just trying to BS me? And one
Right,
of the responses that I got that, and reflecting on it was like really insightful. Like it's always trying to BS you. That's all it's doing is trying to BS you to produce some text that you will think is reasonable. And, you know, to its credit, a lot of times it's right, but that's all it's trying to do.
right, yeah. And especially when it comes to factual stuff, or even like, it is a very useful bullshitter in some sense, right? So because when it's right or when it's partially right, that's still useful because it is what it is. But that when you put that label, like if they had sold it as like, hey, we have built a really good bullshitter, right? Like, and it sold that as a product, then people would know, okay, not to use it for a bunch of tasks that they're currently thinking of using it, right? And so, yeah, so that's the sort of divide that in messaging that somehow researchers and NLP folks know, oh yeah, language model loss. Obviously, all it is doing is blah blah blah, right? And yes, RLHF can help to some degree, but clearly it's not going to be able to do these bunch of other things all the time, and that kind of thing is missing from general public, but also how a lot of people are planning to use it, for example, right? So I think that aspect is the part that we need to think a little bit more about.
You've got Palm, Minerva, Flan down. You know, tell me a little bit more about your take there, because I hear of them, you know, in a vague research context, because no one really has access to these, but Google, as much more so than something that is huge from a commercial perspective. Is this a prediction, or is this a reflection?
Yeah, so no, I think of this as Palm was a huge commercial development this year. Like Google built this really large model. Now there are obviously they haven't released it, right? So what's the ideal situation? They completely release it open source, everybody gets access to it. That's not going to happen. Another possible thing is they put an API on it and charge people. From a Google perspective, that doesn't make sense, right? So it is something that they've built. It's valuable internally. I'm sure it sort of has there are reasons not to make it public, but it also has a lot of research insights because nobody else has such a big language model trained in a similar way. And I guess I want to give them props for at least publishing and evaluating and doing things like that with Palm. Um because it is of a size that we will not see for maybe another year or two to be sort of publicly available, but yet we get to hear about some insights, what to expect, what are the emergence behaviors um, coming out of those language models, right? So yes, it would be ideal if we could audit it, and all of us and I could contribute in finding out what the problems are and when it works and when it doesn't work. But given that, I think they did a good job. Specifically, what I will say is that that size has brought up a bunch of capabilities, like the whole chain of thought thing that we talked about at the beginning, that somehow became possible at that size but wasn't possible at other size, right? So
So that's why that research is also all coming out of Google, because it applies mostly to uh, you know, to language, to LLMs of that size. Palm is 540 billion parameters.
something, yeah, 540 years, yeah. So I think they have access to it and they can produce a string of papers, and yes, nobody else can write those papers, but from a consumer of research as well as producer, right? So from my consumer side, I love to read research, and I'm glad that they're writing those papers because there's a lot of interesting stuff in all of the papers. So yeah, there's a whole string of papers that I would recommend, and I can point you to them offline. But yeah, there's stuff that we'll see happen publicly next year or maybe another year after that, when those models become commoditized. So yeah, no, I think that's been kind of key.
So I'd say for that, commercial but not commercialized.
Yes. Right, yeah, or soon to be commercialized, I'm sure, but maybe not by Google.
Yep. Awesome. Next up, kind of the intersection between search and LLMs. What are you seeing there?
Yeah, so I think that's been kind of an interesting, it's been a commercial development, again questionable to some degree, but because I don't think the research is these models are quite up to snuff. But uh, this somewhat coincided with ChatGPT. I think
Well,
there were
ChatGPT certainly raised a ton of questions about, hey, is this a Google killer?
Right, right. Yes, exactly. And along the same time, there were at least three search engines that I know of. There was Perplexity.ai that I don't think existed before what the product they came up with, which is a search engine which sort of gathers all of the results from a typical search engine, but then uses GPT-3 like models to summarize the content of those links and produces a paragraph that actually answers your query. U.com is again a search engine that has been around for a while, but they brought this whole chat aspect to their search where you're sort of chatting and trying to come up with an answer. And again, it's sort of not just showing you a bunch of links, but composing information into text.
That's Richard Socher's company, and we'll drop a link to my interview with him in the show notes as well.
Okay, cool. Yeah, yeah. And Niva is another. It's a private search company. It's a startup that also has an AI agent that you can talk to and things like that, right? So I haven't played around with all of them. I've played around with them a little bit, and again, it's very easy to find problems and sort of realize that okay, these language models are this interface is great and it would be great to get the right paragraph if it could get there, but oftentimes they don't quite work because of sort of fundamental issues with language models. But I think from a commercial development, I'm pretty excited about what search would look like in the future and where language models would fit into that whole product.
Yeah, one of my thought experiments with this in the context of ChatGPT, not that it was particularly deep, but like there was this early meme, along the lines of, "Hey, Google search is crap now; it's all ads." Uh, ChatGPT, I love this interface. It's going to kill Google, and so I asked ChatGPT to basically build a response with an ad in it. It works. It can do it. I wouldn't be so sure that your, LLM based search won't have any ads.
Right, yeah. Yeah, no, I think yeah. Where the ads would come in and how subtle the ads will be once you throw in a language model into it. Yeah, that's kind of interesting to think about. Yeah.
And I guess next up on your list of commercial developments is what I might call the LLMing of all the things.
Yeah, so I think it's been 2 years or so since GPT-3 came out, and it's the question of like, okay, where is the world changing products that are using GPT-3? When it came out, hey, it was going to change everything. Has it changed everything? And I would say, like, for the most part, no. The products that did seem to show some promise, and some of these are ones that will appear in the future but have been kind of semi-announced, is the notion of writing assistantship, right? So I think Notion AI is the one I think about, where a lot of people, it's a mainstream product, anybody can use Notion, and Notion has this GPT-3 thing built in where it can write to-do lists for you and things like that. So I think that is a pretty strong first version of GPT-3 as a commercial product that anybody can use, that I'm quite excited about.
I feel like the timing there is very ChatGPT influence. Obviously, they've been working on it. They saw it when GPT-3 came out, but I think they made it available right after ChatGPT. And a lot of these, Jasper's been around for a while, but there's a lot of new kind of writing assistant types of things. And it just does seem like there's a step function increase in kind of energy in the space of using LLMs since ChatGPT, even though they're all based on GPT-3, which has been around for 2 years, right?
Yeah, so I don't know exactly why that that thing seemed to align well, right? So it's like, yeah, GPT-3 was announced, but it was a while before the API was rolled out to everybody, and maybe after that it takes a while to make the business case for these things. So yeah, maybe it's just timing of why it worked, or there were people like already kind of working on it in a sort of on the side, and they were like, hey, no, we gotta sort of ride this wave and sort of introduce things, right? So I don't know exactly what that looks like, but yeah, no, I think the fact that it aligns also gets a lot more excitement, and people know, oh, okay, ChatGPT is something I've played around with. This is now ChatGPT that's working on something that I do, and there's a lot of value in that.
Am I detecting an underlying uh, pessimism, maybe, about like, kind of, where's the flying car that I was promised? All I have is this GPT-3 thing.
Well, it's not so much the pessimism, because when I saw GPT-3, it became evident to me that this is a great language model, but it's not clear as it is how it can be made into a product, right? But it still came with a lot of hype, and yeah, it can generate a bunch of things, but we quite haven't quite seen what the product version of those look like. I think the large language models are extremely powerful, not just as language models, but they can be converted into products. I don't quite feel like we are at a stage where it's just going to be through prompting and, let's just tweak it a little bit. I think there are a bunch of products that will come out of just by doing that, but there's a whole slew of product where the language models need to know a lot more about the context where they're going to be able to be effective. Effective tools.
And you mentioned Microsoft. What did you have in mind there?
Yeah, this was sort of a news that came out recently where they're trying to have a bigger stake in OpenAI, but also just generally thinking of having OpenAI like tools available in Word, available in PowerPoint, and all of these things. They don't have it yet, but I think those kind of things are just sort of coming as well.
Do you think a Chat GPT based Bing is a Google killer?
Oh, I don't think with that branding they would have to call it something else, or yeah. At this point, yeah.
I mean, that seemed to be the suggestion, right? Chat GPT comes out, they're gonna take a big stake, and it was mentioned, if not in the official announcement, it seemed to be the conjecture that it was gonna be, some tie up with Bing, to explicitly to target search, right?
I think there needs to be a lot more fundamental work, and we can talk about this in the future predictions. But there needs to be a lot more fundamental work before we sort of are able to kill search just by putting a language model, right? Like I think that gap is not as simple as replacing something or just augmenting existing search. I think you would have to think about what kind of things can language models actually do, and you still want to rely on sources and things like that. But yeah, so I think it's going to happen at some point, but it's going to be like search it won't be replacing search because it'll be a different thing, right? Like it's not going to be search
Not in
because
the way we think about
search
search right
literally
now, at
means
least. Yeah, yeah.
exactly. So it'll be question answering, or it'll be something else, right? Like it'll be a helper or some whatever. But search is maybe not the right thing to think.
Well, one quick thing before we jump into predictions, you kind of reflected on your top use case for the year, and that was Copilot. Tell me a little bit more about how you're thinking about that.
I think Copilot came out probably not exactly in this calendar year, but I feel like it got a lot more adoption this year and started becoming part of the tools where people are coding. And personally, I started using Copilot this year, so I'm going to put it in top use case this year. And I will say before Notion.ai, Copilot was probably the only use of large language models that I saw anywhere. So from that point of view, it was interesting that GPT-3 came out and then nothing that can till Copilot. But from a use case point of view, it has been incredibly useful, right? So I've been able to do things. It has made me a lot more effective as a coder. Not that I code much, but when I do, I want to do a lot, and Copilot has let me sort of do that. And that's been amazing. It's I feel the right combination of, hey, having a nice user interface, having the right data that it's trained on, to be able to sort of really help people in what they want to do. Now, of course, Copilot has issues. It's producing uh, code that can be dangerous, that can be buggy, and of course there are the questions of copyright and plagiarism. Exactly. So I feel like I hope those things will get resolved. But those are, again, when you start using a language model, these are the issues that you have to solve. And I'm glad that Copilot is bringing all of these things into the discussion by it being out there.
Yeah, I've had the same experience with it. I think I've shared this on social or in the podcast in a conversation. I, you know, saw all the Copilot demos, played around with it with, kind of the toy problem things, but I don't do a lot of coding necessarily. But I do tend to binge on coding every once in a while. Like, and usually like that end of year holiday thing, I'll have some project. And I did that this year and used Copilot. It was amazing. Like the productivity it helps, the productivity it helps create for you attacking a new problem with new tools without the context switching of going to Google and Stack Overflow. Like it's incredible. I'm a total believer.
Yeah, and I think that exactly is the kind of thing I expect language models to be useful for. They are not going to, and with ChatGPT going back a little bit, people are talking about, hey, people are going to lose jobs and it's going to change everything, and we'll replace XYZ with ChatGPT. And I don't quite see that happening. But I do expect a lot of people in many different areas becoming a lot more productive because of ChatGPT, right? And Copilot is an example of how language models can make you a lot more productive, um, without replacing. I don't think it's replacing specific programmers. It's just allowing them to do a lot more, and that I think is the best use of technology.
Awesome. Awesome. Well, let's jump into predictions. What are you most excited about kind of looking into your crystal ball?
So I think the ChatGPT is the one that sort of everybody knew language models. They're just trained on data and making predictions. What ChatGPT really did was remind everyone, like, okay, even if the language modeling part is quote unquote solved, right? Even if you get a really, really large language model, that doesn't mean you're done, right? And I think one of the biggest aspects of that was making sure that what you're generating is not just BS, it's somehow valid, somehow the truth, somehow something that you can cite and rely on, right?
They definitely shine a light on how challenging that is, right?
Exactly. Yeah. So I don't think this is going to be a prediction necessarily for 2023. Maybe 2023 is when we'll start seeing the first attempts at this. But being able to generate text does not have misinformation, that differentiates factual from creative hallucinations, that is able to cite its sources and sort of point to, like, look, this is the piece of paragraph that I'm based on which I'm generating a piece of text. I think those things are needed, and it's probably going to be the next aspect of language models. That's going to be a big topic of research.
Do you have a sense for how we get there? Is it kind of applying the same tools, RLHF, for example, attacking this specific problem, or do you think there's, you know, we don't have the tools and it's going to need to be kind of new invention that gets us there?
I think it's going to have to be new inventions, and I want to sort of think of it as not just, you know, how do we attribute it to specific pieces of text, but I kind of think of it as like being able to use other tools, being able to use other things available to the language model when it's being trained as well, right? So it should not rely on memorizing facts to any degree. It should just rely on using existing tools, including search, including maybe calculations, maybe even a Python interpreter, whatever else it needs to do, but still be able to do the language modeling task, right? So I think there is some combination of being able to refer to external stuff and still do language modeling that we quite haven't quite cracked it, and that would be something that I think will come into picture. I'll give you an example of how sort of some people have been thinking about it. There's this whole idea of retrieval based language modeling, where you're still generating the text token by token, but you're always retrieving some set of documents and you're conditioning on them when you're generating each token. That's sort of one step towards what I'm talking about, where at least you're trying to look at retrieved documents when you're generating, but that doesn't guarantee what you're generating is actually based on it.
So you spoke earlier about the decomposed reasoning. Is this prediction that those ideas become more real in some way in 23, 24, or is it that what we're doing with a trained model uh, to kind of get decomposed reasoning. We're going to push even deeper into the fundamental creation of the model, like at train time and other things.
Yeah, so more of the latter, right? So right now we are expecting the model to be able to do decomposed reasoning, but we only do it at test time in some sense, right? Let's actually try to start thinking, putting that stuff during training, right? So like, again, I don't want to make this analogy too much, but when you think about when you're training a human on how to do things, you don't just give it pairs of input and output. You give it a little bit more of a decomposition, and then based on that they're able to do what they do. If you want them to use the Python interpreter, you don't just expect them to finish it on their own. They can use the interpreter when needed, kind of thing, right? So I just think of language models as, yeah, maybe they're still doing the language modeling task, but they have access to a bunch of other tools. Um, and maybe this is more far-fetched than 2023, but I think in the long run you want a system that's able to do those things.
You got your next prediction is around diffusion models. It's kind of surprising that that term hasn't come up yet so far.
Yeah, I guess it is surprising, but also in NLP in general, I feel like we are barely scratching the surface of what diffusion models can do. So yeah, I think clearly in the image generation space, we've seen a lot of progress with diffusion models, and we've seen some in NLP, but not enough. I guess what I find attractive about diffusion model is that it's trying to generate more than just a single thing at one point, right? So if when diffusion models are applied to text, the way it would look like is not just producing one token at a time. It will try to produce a whole sentence or whatever we decide is the right granularity. And that idea of a model that is trained not to do one token at a time, but to do something bigger, really appeals to me, because I feel like a lot of the issues we talk about with language models fundamentally come from the fact that it's trained to do one token at a time, and sort of and that's kind of the loss, right? So if we can have the model be trained um, to generate more and then give it a loss, I think that's fundamentally interesting, and diffusion models sort of provide one way of doing that.
Do you would you kind of visualize this as, a model like, in a first iteration spitting out bullshit and then successively like iterating towards truth? Like, is that one way that this could play out?
Yes. Well, I mean, probably not. Probably it's going to be somewhere in the latent space. But I think the way I think about it is like, if we were doing this token by token thing for images, it just wouldn't make sense, right? Like, uh,
It
predict the
certainly
first
wouldn't
pixel.
produce the images that we see coming out of
Right, right, right.
stable diffusion and
Yeah. Or
similar.
even what it's going to learn is going to be something different. What it's going to learn is, given the image that I've seen so far, let me predict the next pixel or the next piece, right? That somehow feels like a fundamentally different task than being able to generate an image fully, right? And so I feel like thinking about the same idea for text just kind of makes sense. Like, you write the summary in one shot and realize how wrong it is. It feels like something fundamentally different than, hey, you got a bunch of tokens correct, but you also got a bunch of. And in some sense, there are some analogies to RLHF and using PPO for training, for example, where you try to make sure it's fluent and things like that. These are all losses designed on not just a token by token basis, but something that's longer. And so we've known how useful they've been. So I feel like there may be something in taking that idea and applying it to pre-training is something that would be useful.
Interesting. Interesting. I expect a lot of people will be wanting to figure out how to do that.
Great.
And online updates to models.
Yeah, so I think one of the problems with language models, so let's keep aside the grand vision of like how language models will use search and all of these other things. But one of the fundamental problems with language models is that the world changes, but they don't. And this seems to be a fundamental sort of issue with language models, right? So I think thinking about how we can update language models every month or every week or every day, right? I think um, is an interesting problem to be thinking about, and becomes increasingly relevant where BERT doesn't know anything about COVID, so it's not useful for a bunch of applications, even though otherwise fundamentally there's nothing wrong with it, right? That kind of stuff is just uh, not fun. And I think there'll be research on trying to sort of fix that.
What's the current, not necessarily state of the art, but kind of current approach for doing this, at the scale of a GPT-3? Like, is it, collect more data and retrain from scratch, or um, how did they approximate or approach some kind of incremental training ability, if at all?
Yeah, so there hasn't been that much work on that front. I would say this is something that's yeah, needs a lot more attention. Yeah, but I think there've been parameter efficient training on sort of how can we uh, slightly improve the, like, change the model but not completely change it, find the set of parameters that we should update so that it's not updating the whole parameters but updating a little bit of it. Things like that I feel are around, but need a lot more work.
Kind of the one way to think about the fundamental problem is with the transformer, it's not like a layered architecture like a CNN where you can just chop off the n layers and retrain from that point. It's just a much more complex and interconnected model, so that kind of incremental updating doesn't work.
Not so easily, yeah. I think there's been some work on sort of taking, like, hey, 1% of the parameters sort of spread over the transformer and updating them with new text. But I think, yeah, solving this problem is going to be something that needs to happen pretty quickly.
So to be clear, taking a step back, like this is all the looking forward section. Those three things, kind of misinformation and attributable generations, diffusion models, and online updates, were specifically in your category of the greatest, most exciting opportunities in the field. Areas where we're likely to see a lot of research attention. Um, and possibly some really interesting results coming up in the next year or two.
And also sort of fundamental problems that need to be addressed by language models. Yeah.
And so that brings us to your top three predictions for the field proper. What do you see there?
Yeah, so I think, and maybe some of it is riddled with disappointment as well. So the first one here is multiple modalities. I think there's been a lot of exciting work, so I don't want to sort of take that away. But to me, after GPT-3 came out, and then you saw Clip and Dali and Whisper, and now there's video models and things like that. To me, fundamentally, I understand technically why they're not the same model, but it's still a little bit disappointing that they're not the same model, right? Like, why is there not the same model that trains over the same data GPT-3 is trained on, but also on the Lion data set that does all the images and text and audio and video and stuff like that, right? And I think um, this is a sort of near future prediction, is that we are going to see ways for pre-training models that cuts across multiple modalities. And I think Clip was a good example, sort of early example of like what you can do when you have a lot of text and images. But I think, it still didn't have access to a lot of text only data. And I want a model that can do chat GPT like things, but also generate images for me, and maybe read them out and things like that, right? So I feel like multiple modalities is an exciting sort of kind of an opportunity, but definitely something that's going to happen soon.
Yeah, when I first heard you describe this, I thought, well, multimodal, like that was the big thing we were talking about in these trends conversations last year. But you're going a level deeper. You don't want multimodal use cases or outputs. You want a single architecture to do multimodal things.
That's what I want. My prediction is maybe going to be a little bit more grounded, so to say. But yeah, like video, for example, is a more concrete one. Like text to video, we've seen some initial versions of those. That's probably where a lot of initial stuff would go in. But I've been really excited about sort of the Mind Dojo world of like playing with text and Minecraft and having an agent that can do a bunch of things in Minecraft. I feel like there are things that models can learn from images. uh, Even for language modeling, it would benefit to see a lot of images in some sense. Like there are just a bunch of things in images that we never talk about in text. And but so from an AI agent, I think it's useful to think about something that has access to everything. But yeah, more concretely, we're just going to be pushing them sort of pairwise. Like, yeah, it's going to be audio and images, and there's going to be a bunch of other pairs that'll happen first. But eventually, I think having actual multiple modalities, not just greater than one modalities, would be the exciting part.
Hmm. Awesome. Awesome. Next up.
Next, I'm kind of excited about better training and better inference, and better in the sense of being more computationally efficient. I think this is an exciting work that a bunch of people are already doing, but I think this is just going to become increasingly important from a sustainability point of view, but also from like universities surviving and doing interesting things, and small companies contributing to research. I think it's important to be able to train these models, to be able to run these models, and there's going to be a lot of research in trying to do those kind of things.
Hmm. Hmm. And you've got a few examples that we'll link to in the show notes. Anything that you want to point out?
Yeah, so let me mention two that I saw recently. One of them is this paper called cramming, and the idea here is to, they think about the scaling laws paper, like, hey, what can you do when the models get larger and stuff like that. The cramming paper sort of turns it on his head and decides, okay, what if I have just one GPU for one day? What's the most I can do with that? And it's a very sort of different question, but it somehow is a lot more relevant to many more people, because a lot more people have a single GPU for a single day. And they show that you can get almost sort of BERT level performance if you make the right choices, and they sort of detail what those choices might look like. It's a paper, but I think I like that idea of like, hey, what if we were scrappy about training these models? How far can we get? I think that's a very interesting question that Google and OpenAI is not going to be asking, but might be relevant for a lot of NLP research. The other one I want to talk about is this Petals work that came out of the Big Science thing. I haven't read too much about this, but it seems like a really interesting idea of the problem of running really large language models. So even if OPT releases 175 billion model, how do you actually run it? It doesn't really help most people. Even if you have a big cluster, it's kind of difficult to run it. So what this Petals does is they're building this framework for using the ideas behind BitTorrent, of sort of distributed computing, and bringing it to language models. So like, hey, you should be able to run these 100 billion size language models distributed over a bunch of commodity sort of consumer computers. So yeah, I think this is an interesting idea. I haven't played around with it to see how far you can push it, because partly you need a bunch of people also running Petals. But once we get there, I think that can be a pretty exciting way to run language models.
Interesting. Interesting. So your third prediction is editing and revising models. What do you mean there?
So these are these family of models that are not so much interested in generating text, but taking existing text and editing it. Um, and I think this is a very interesting idea that can become increasingly important. And in some sense, this could be the way you fix language model output potentially, is to have another model that takes the output of the language model and fixes it. Right? So some of the work here, there was a paper out of Julia's group from UW now, that sort of looked at summarization, and there are systems that generate summaries. How can you take that generated summaries and edit it to correct all the factual mistakes it has made, right? And editing is somehow a much, no, let's not say definitely a simpler problem, but in some sense it could be a simpler problem than writing the whole summary from scratch, especially when you do the writing, you do left to right generation, so you can't go back and revisit something that you've done before. With these editing models, they have the whole picture to some degree, and all they have to do is fix it so that the picture is consistent, right? And so this idea seems like potentially simpler than generation. So you could generate something, and maybe this is also attached to diffusion models, where you write something that's maybe not so correct, but you revise it and it becomes better. So there is a bunch of work along these directions that came out essentially this year, and maybe second half of this year. Some of it early on, that tries to gather data sets where you have edits, or try to maybe even generate data sets where you have edits, and create these models that are able to fix those edits in some sense, right?
And so the prediction specifically is that teams will build on this and produce models that can actually kind of deliver on, the ability to do editing and revising.
And I think this could be, for example, there'll be an editing model that can fix bias issues. There'll be an editing model that fixes toxicity. There'll be an editing model that fixes factuality, right? And these editing models can make web searches and sort of take that information and edit the output, right? So I could imagine that this could be a practical way of solving many of the issues in language models.
It is a really interesting idea that I don't know if it's like a separation of concerns or something. Like the language model doesn't necessarily need to do everything if we can compensate. So in a way, it's like decomposition as well. Like let it generate. And if the way to get something that's not toxic, that's accurate, is to have another type of model support it, great.
Yeah, I think yeah, that's right. And then for at least for summarization and things where it's supposed to be factual and stuff like that, I could see it sort of addressing those problems. Of course, if it's generating a long text and there are longer range sort of consistency issues and stuff like that, it might be a little bit difficult for editing models to come into picture there. What I like about editing is also it's something that we can imagine not only working on language model output, but working on human output, or text that's been written with a writing assistant and things like that, right? Like you can still go back and do a post processing editing step to polish it up, and I think that could be pretty useful as well.
So our last category in the NLP predictions is top people, companies, organizations, teams to watch in the field 2023. Of course, the caveat of you're not any omissions here are not to slight the work of any particular team, but like who's got your mind share, and who are you expecting to see interesting things from in the upcoming year?
Yeah, so this has been a little bit difficult question, I think, every year. But one thing I will say, and this is maybe the most obvious answer, is to sort of keep an eye on OpenAI and what they're up to, right? I think people, once they do something, people always come back and say, look, what they've done is not so exciting. Oh, they only scaled it up, or oh, they only did this additional thing. But the fact is that they are the first ones to do it. They're the first ones to bring it out, make it available, and that is and get people excited about uh, language models in a way that they weren't before. So that happened with GPT-2, GPT-3, and ChatGPT, and I'm sure GPT-4 will have the same thing. I'm sure retroactively we'll all talk about what the problems with GPT-4 are, and how it's incrementally only training on more data, or has more parameters, or whatever it is. But I think qualitatively it'll bring something interesting to the table, and I'm really curious about what that next interesting thing is going to be. Right?
Do you think the general predictions that are kind of floating around, basically spring and 100 trillion parameters? Um, do you, is your money on those?
I mean, to sort of have a completely different perspective, I think this is also a nice model that came out. This nice paper that came out a little earlier called the Chinchilla paper. This was a paper that showed that these models are extremely undertrained and they are data hungry. So one version of GPT-4 could be potentially not even a different architecture, not even more parameters. Like exactly, let's keep it 175 billion, and let's just somehow get 10 times the data if you can potentially get that from somewhere, right? I could
But
totally
then everybody that shared the image with the little dot and the big dot would be totally wrong. Like,
well, yeah, they'll just sort of replace that with data, and it might still still work out, right?
yeah. For
So
those not on Twitter, that has dominated LLM Twitter over the past couple of days. Is there even? I think that when GPT-3 came out, the kind of colloquial articulation of what they did was like train this language model on the entire internet. Like, is there 10x more data to train on?
yeah, I don't know how much they've trained on and how much there is. I mean, there's definitely 10x more data. There is a lot of stuff on that's proprietary, right?
Proprietary, yeah,
Maybe even
or
proprietary, right? Like
transcribe a bunch of videos and audio and books, and I guess, yeah.
they do have that whisper model that that does, yeah, that does really good transcribing, so they could use
Good
that.
point. They didn't create that for no reason.
Right. Yeah. They also can go into scientific papers, and like I don't think the 48 million papers that Galactica was trained on was something GPT-3 was trained on. And I think that is a pretty valuable resource. That Galactica paper also showed that even on mathematical reasoning and things like that, they were actually better. So these scientific papers may be useful for a bunch of other things than that we don't realize. So yeah, I think where that data comes from is unclear to me, but it's clear that more data is somehow maybe even more interesting than more parameters. And more data could include more RLHF style things, right? Like I don't know what OpenAI has been gathering.
Okay.
The other top company to, I would say again, continue taking a look at is Hugging Face. I've been constantly sort of amazed by how much they've been doing. One of the sort of key insights is like EMNLP, which is this top conference in NLP, has this demo track where they highlight sort of not research papers, but uh, products, sort of demos that are relevant for research. And for the last 3 years, I think at EMNLP, Hugging Face has got the best demo paper award, right? And that's that kind of thing sort of shows how they've been doing very different things, but also doing things that are impactful and interesting. So the two I want to highlight this year is, again, they've done many things, but the one I want to highlight is the evaluate system, where they had this whole evaluation framework for reproducing evaluations and evaluating models and making all of this stuff really easy. So you can introduce a new metric and evaluate it on thousands of models and things like that. Make it really easy to compare models, make it really easy to reproduce papers. And I think that that's a really valuable service to research. And the other one that I sort of, we also started with this of like, hey, what's happening inside the pre-training data? One of the tools they have is this roots search tool that takes the roots pre-training data but allows you to search it and find all kinds of things that are happening inside that pre-training data. So if you have a specific prediction, then you want to be like, hey, is there anything in the training data that looked exactly like this? You can do that search and get some results. So I think they're just being pretty creative and thoughtful about what is useful and building tools, and that's been exciting. And the last one that I'll bring up, and this is something that was in my on top of my head this week, but it can change. It's a group called OUGHT. It's OUGHT. I believe it's ought.org. It's a website. And this is sort of a research nonprofit. And they've been doing sort of interesting things related to sort of building tools. So they have this tool called Primer, and this is going back to decomposed reasoning. This tool called Primer, sort of, you can give it a question and it tries to come up with an answer. But in the process of coming up with an answer, it can do a web search, or it can write a small program, and it can do all of these things. And they've built a sort of nice tool to be able to visualize what the decompositions are and what sort of things are being done. So it's a really interesting use case of language models. Um, and then they also have another tool called Elicit, which is in some sense it's a little bit like Galactica, but it's not so much interested in generating papers for you, but helping you do research for your paper, right? So you have a specific question, it's going to find a bunch of relevant papers, take out snippets from those papers, and be able to do that. So I don't know. They've had have a bunch of tools that when I'm looking at decomposed reasoning, it comes up. When I'm looking at research assistants, it sort of comes up, and so it's been interesting to see, and I'm curious what they'll do next.
I'm really curious about that. I'm going to look into that in more detail. Awesome, awesome. Uh, well, I think we are done. Like you've been a champ. This has been awesome.
It's been
Awesome.
fun, yeah.
Yeah. No, I mean, you rose to the occasion of kind of capturing an amazing year in NLP for sure. So thanks so much for joining us.
Yeah, thanks for inviting me. I think the time sort of justifies how much this year had in NLP this year, and I'm really curious to see where NLP is going to go. I will mention that ChatGPT came out right before, or I think maybe even during Europe's. So I attended Europe's, and I saw the first hand experience of the whole machine learning community there. Then I flew to Abu Dhabi to attend EMNLP, and that's where I saw the reaction of the whole NLP community. And it's been interesting to see sort of how the reactions have sort of spanned both optimism and excitement, which is kind of where I am. Like to see like, hey, what can we build with this stuff? Uh, to pessimism where they're like, oh, it doesn't really, yeah, it's not going to change anything. It's just a bigger language model, all the way to essentially, I want to say some form of denial, where it's like, look, it's behind proprietary closed off system, and therefore it doesn't matter to do research. And that's definitely not a take I agree with. So yeah, it's been exciting. And
And there's also a fourth, which maybe is less so, and I don't maybe less so in the research community than in the general sphere, which is fear of the implications of it. Um, did you find that less so on the research side?
I guess less so, definitely less so on the, yeah, because I think we've been there is a little bit of fear becoming a little bit more obvious, but I think the community, because of a lot of people who've been sort of pointing out problems with large language models for a while, we are kind of we know what not to. We as a community we should know what not to do. But it is a little bit scary when people are using it for things that clearly at the onset should be like, hey, why are you doing this? Right.
Yeah, yeah, yeah. Awesome. Well, once again, Sameer, thanks so much. Really great session and conversation, and appreciate all the work you put into prepping for it.
Yeah, thank you, Sam. This was fun.